Today we are talking about solving polynomial equations. This is section 5.3 out of our textbook. And we are going to solve those polynomial equations by factoring and by graphing. So, to remind you the steps to solving, or let you know what those steps to solving. First and foremost, just like anything we've done past linear, is you want to write that polynomial in standard form. That's what you did at the beginning of this chapter. You practiced that. That means that you're going to set it equal to 0. And after you have it set equal to 0, then you are going to factor the polynomial. So yes, you thought we were done. We're not done with factoring. Okay? And then you're going to use the 0 product property to find the roots. Roots, also known as solutions. Okay? We use those words interchangeably. And in case you don't remember what the 0 product property says, if A times B equals 0, then we know that A equals 0 or B equals 0 or both. Okay, so we've done that. We've talked about that yesterday in our lesson, or the previous lesson. And anything, if you multiply things and you get 0, then we know that the factors, at least one of those factors, has to be equal to 0. So let's continue. So some of the examples of problems you'll see, what are the real or imaginary? So that does mean that we are back to your friend of I being in the answer. Okay, what are the real or imaginary solutions of each equation? So y'all never, ever, ever want to multiply this out. If it's in factored form, you're going to take each factor and set it equal to 0. X squared minus 1 equals 0. X squared plus 4 equals 0. So this, because I have no b term, this is what our square root property allows us to do in solving the equations. X squared equals 1. I'm adding 1 to both sides. And then I'm going to take the square root of both sides. And when I do that, I always have to remember plus or minus. So that's plus or minus 1. And over here, again, no b term, so I'm going to take the 4 to the other side. That means negative 4. And again, I'm going to take the square root of both sides, and I'm going to get that x equals plus or minus. Remember, that's 2, but that negative underneath means I'm going to have an I in my answer. Okay? So my answer is going to be x equals plus or minus 1 plus or minus 2i. Okay? All right, look at the next one. X to the fifth plus 4x cubed equals 5x to the fourth minus 2x cubed. So remember, the first step that we're always supposed to do is make sure we have it set equal to 0. Okay, so I'm going to take these terms over to the other side. I don't know why that came out like that. So that gives me x to the fifth minus 5x to the fourth. And then those are both cubes. So plus 4 plus 2 is going to be plus 6x cubed. And now we have to factor. And I hope you realize that the common factor here is going to be x cubed. So that's going to leave me with x squared minus 5x plus 6 equals 0. And I have to factor that. And since that is 1, a is 1, then I know I'm going to have x and x. Okay, and as we continue to talk, I'm looking for the factors of 6 that add to give me 5. And that would be 3 times 2. And if it's a sum, the signs will be the same, and they'll be whatever that is. So I need negative 5, and that, of course, gives me negative 5 when I get my minus 3x or my minus 2x. So I'm back to setting each factor equal to 0. So x cubed equals 0. X minus 3 equals 0. And x minus 2 equals 0. And so that tells me, of course, cube root of 0 is 0. So this one has given me x equals 0. This one y'all know I add 3, so x equals 3. And here, x equals 2. So those are my zeros. Okay, so we are going to take this time to review some factoring techniques that we've already talked about, give you some examples, and introduce a new one. I know you'll always want a new one. All right, so look here. So first off, remember the first thing you always want to do is factor out your greatest common factor, GCF. Bad job of underlining there. So the GCF here is a variable. Actually, I have a number. I'm looking at the numbers first. Between 12, 8, and 48, the number is 4. And I have an x in every term, so I take the lowest exponent. So x to the third. So 4x to the third times 3x cubed is 12x to the sixth. 8 divided by 4 is 2. And if I had 4 and I took 3 out, I have 1 left. 48 divided by 4 is 12. And x cubed, so that's kind of the whole thing right there. I didn't have any x's left. So that's an example of factoring out the greatest common factor. Always look for a number and a variable. Our quadratic trinomials, that's what we've done a lot, but you're always looking for the product of a times c. And it says the sum of b. I use the sum or difference because obviously if the sum is negative, that's the same thing as the difference. But that's what we've been doing all along. And here is an example of one, and they gave us 2x and 15, which is 2x and x. But I'm looking for the factors of 15 times 2. So a times c is 30. And I'm looking for those factors, and this tells me I want them to add to get to 11. So I have 1 and 30, 2 and 15, 3 and 10, 4 doesn't go. Oh, there we go, 5 and 6. Y'all probably did that faster than I did. But that lets me know that it's going to be 5 and 6. And we generally break that up. There's another way that I can do it I won't explain right now. But that's going to end up being 2x plus 5 and then x plus 3 because I'm trying to get to 15. And if you have some questions about that, come see me. But we broke it up, okay, and we would know that this would be 5x and 6x, okay? And you did the factor by grouping, which we're going to talk about later on down here. Okay, then we have our PSTs, perfect square trinomials. Okay, when you look at that middle term and take half of it, square it, you're going to get that. You'll see as we go. So a plus 2ab plus b squared is a plus b quantity squared. If it's minus, it's a minus b quantity squared. So if I have x squared, if that's a perfect square and that's a perfect square, I take the square root of that, which is 7. That's going to go there, and I multiply it by 2, and that's going to be 14x. Okay? Difference of two squares. We keep talking about that. Y'all are getting really good at it. A squared minus b squared becomes a minus b, a plus b. Does the order that I wrote those in matter? Absolutely not. 3 times 4 is the same as 4 times 3. So look at this though. They're getting a little fancy on you because that's not a perfect square of what you're thinking, but look at how they factored it. They just took the square root of that number. So the square root of 6x squared is 4x and 4x. One is plus, one is minus, and the square root of 11 is just the square root of 11. Shows some versatility in your factoring. Okay, and factor by grouping. Okay, so this one, remember we took the common factor of the first two terms, which here is going to be a times x plus y, and then we always take this sign plus, and the common factor of the last two is b times x plus y. Uh-oh, school's over. And that gives me, and then we find the common binomial factor. And so I take that out, which gives me x plus y times a plus b. Okay. So in this example here, x cubed minus 3x squared, the common factor between these two is going to be x squared. leaving with x minus 3. And the common factor here, it's always a good idea just to write that 1 out, because then when you take out this common factor of x minus 3, then what you have left is x squared plus 1. Okay, so we've done that a lot. All right, so here's the last one, and it is the sum or difference of two cubes. Okay, we had perfect square trinomials. This is when it have two terms, or this is kind of like the difference of squares, but we could have a difference of cubes or a sum of cubes. And this is what happens. You take the cube root of each term, a plus b. Okay, then using this factor, okay, it's really similar to that one up there. You square the first term, you change the sign, multiply them together. So sorry about all that noise. Multiply them together and then square the last term. Okay, so watch it again. This time it's just a minus. So I take the cube root of each one without changing the sign. And then using this factor, I square the first term, change the sign to what I see, multiply them together, and then square the last term. Okay, now some people like to call this form SOAP because this side sign is the same as that sign. See, plus and plus, minus minus. This sign is the opposite of whatever you have here. And this last sign is always positive. Okay, we're going to pause for a second. So since that's a pattern of sum or difference of cubes, you also want to remember the cubes that we've talked about earlier on my thing going wacky on me. Okay, remember our cubes? So if we have, I'm just going to put x and x cubed. This is an abbreviated version of that chart, y'all. 1, of course, is 1 cubed. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. So you need to recognize those numbers or else you're not going to be able to see something like this and know that that is the sum or difference of two cubes and something that can be factored. So when you do it, a and b, that's basically taking the cube root of both of these. So we have the cube root of 8, which is 2, and the cube root of x cubed is x, and the cube root of 27 is 3. So that's my basic factor. And then I told you square the first one, so we have to square the 2 and then square the x. And then we change the sign. It's always the opposite. Then we multiply the 2 together, so that's 6x, and then we square the last one. So that's how it factors. Okay, something else that you need to keep in mind when you factor this, okay, this one that you have left here, or this part of your factoring does not factor further. Okay, so you're going to see as we go through what you're going to have to do when you deal with that kind of problem. Okay, another little variation that you want to be familiar with, and I'm going to go ahead and write it down here on the bottom. Okay, but this one you will see also. If you have something that, let's say it's a to the fourth minus b to the fourth, okay? And what I'm getting at is if anytime these two numbers are even, and we've kind of talked about that, that's the difference of two squares, because it is a perfect square, as we just did from our last chapter, if that exponent is an even number. So if you had a to the fourth minus b to the fourth, then you would recognize or should recognize that that's going to be a squared plus b squared. Oops, wrong one. A squared plus b squared times a squared minus b squared. So that's just an extension of this type of thing here, because we take the square root of it to write that. Okay, so you're dividing it in half. Okay, and then this one doesn't factor any further. But this is what you see up there. So it would become a minus b times a plus b. So just know that that's another variation of what you might see when you're factoring or if you're looking at the difference of two squares. So let's look at some more examples. Oops, went too far. My bad. So what are the real or imaginary roots, so imaginary root solutions of each polynomial equation? So I'm working on A, and if I have x to the fourth equals 16, okay, I'm not going to just take the square root of both sides because that's not going to fly because you're not going to get all of them. So I'm going to bring them to the other side, set it equal to 0, put it in standard form, whichever you need to remember. So that's x to the fourth minus 16 equals 0. Well, that's kind of what I just showed you. That is an x to the fourth, and this is the same thing, so let me write it like this. Hopefully you remember from our powers chart, that's 2 to the fourth. So that means that it's going to factor to x squared minus 2 squared. I'm going to write it like that just so you can see it. And x squared plus 2 squared. Okay, y'all, that's a direct thing of what I just did with a to the fourth minus b to the fourth. So I know that's a funky way of writing it, but I'm just trying to show you how that applies. So this is, and basically, however you want to write it, we're going to set each of those factors equal to 0. So x squared, 2 squared is 4. So x squared minus 4 equals 0. And x squared plus 4 equals 0. So at this point, I can do my square root property. That gives me x squared equals 4. And I take the square root of both sides. And I have to, excuse me, I have to remember that that's going to be plus or minus 2. And over here, x squared equals negative 4. Still taking the square root of both sides. But that's going to give me plus or minus, not 2, because those aren't the same thing. That negative means I have a 2i on it. And so it's going to be that. There's a pattern coming here, so I don't know if y'all can see that. We will be talking about it. Okay? All right, B. B says x cubed. It's cubed, y'all. I got to bring it all to one side and set it equal to 0. So I'm going to take this to the other side. So x squared over there is going to be adding it to x squared. 8x to the other side is going to be subtracting it. So I'm setting it equal to 0. Then I see a common factor. So that gives me a common factor of x. So I have x times x squared plus 2x minus 4 equals 0. And, oh, why did I write 4? Because somebody's distracting me. That's actually minus 8. All I took out was the x. Okay? And so then I'm looking for the factors of 8 that subtract to give me 2. And that's going to be positive 4 and negative 2. And then I set each factor equal to 0. X equals 0. X plus 4 equals 0. X minus 2 equals 0. And so x equals 0. If I take that over, that's going to be a negative 4. And if I take that over, that's going to be a positive 2. So those are my zeros. All right. Oh, look at that one. Okay. So I got to get it in standard form. So I am going to have to distribute here because, anyway, if you have any questions about that, ask me. So when I distribute, that's going to give me x cubed plus 8x equals 8x plus 8. So I am going to bring everything to one side. Okay, and when I do that, that gives me x cubed. Those actually cancel out. It's the exact same thing on both sides. So it'll go away. Minus 8 equals 0. So ding, ding, ding. I hope that's coming off. That's a perfect cube. So this is the difference of two cubes. So it factors to this. So I'm going to have the cube root of x cubed is x. And the cube root of 8 is 2. So it becomes x minus 2, always the same sign. Then I use this factor. And I square the first term. I multiply them together, but I change the sign. So it's the opposite sign. So plus 2x, and then I square the last term, and it's always positive. That's our SOAP. So it looks like that. Okay. Now I'm setting each factor equals 0. So I have x minus 2 equals 0, and I have x squared plus 2x plus 4 equals 0. And this, of course, tells me that x equals 2. But this right here, y'all, whoopsie. Remember I said it doesn't factor, so I'm going to take it over here. Okay, it does not factor, and you know me, because that's um, an even number, I'm going to complete the square instead of quadratic formula. But you can use any one that you want. I might even do both. All right, so here, so that means I'm going to have x squared plus 2x plus something. Have to take the 4 to the other side, making it negative plus something. I take half of that number and square it. And then this is my PST that becomes x plus 1 quantity squared equals negative 3. And then I take the square root of both sides, and x plus 1 equals plus or minus I, because of that negative, square roots of 3, because that's not a perfect square. And so I'm going to end up with x equals, take that over to the other side, negative 1 plus or minus I square roots of 3. So, but I will, because some of y'all probably don't want to do that, I will go back over here and do the quadratic formula. And if I did the quadratic formula, I would have negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And a is 1. Okay, so that becomes negative 2 plus or minus the square root of 4 minus 16 is negative 12 all over 2. And then you got to simplify this, so that gives me x equals negative 2 plus or minus. 12 is, if y'all remember correctly, okay, we just did this, 4 and 3. So this is 2. The negative means I have an I, square roots of 3. See, I don't know why y'all think this is easier than the other one. So there's a common 2 and everything, and what I told y'all to do was to write each one. So that's negative 2 over 2 plus or minus 2 over 2. We'll go ahead and put that square root of 3 up here. And there's your I. But see, then these cancel, which gives us back to here. So like I said, I don't know why you think the quadratic formula is easier, because I think this guy is. So I'm going to write that final answer. X equals 2 and x equals that, so I'm going to add a 2 right here, and I'm going to put that down as my final answer. Okay? So you figure out, you can see from there that mine was a little bit fewer steps, and you're getting used to that process that you're going to use a lot in later math. Okay, by graphing, we've done this before, but let's talk about it again. So we have done this kind of thing before where we have two different methods of solving this. Okay, we have one method called intersect. Okay, and we have the other method that, let's go like this, intersect method, or you have the zero method. Okay, and the intersect method is when you set one side, you basically have y1 and y2, or you have on that other calculator, on the Inspire, f1 of x and f2 of x. That's how they write it, okay? So you would make one side f1 and the other side f2, and I can do it that way. The zero method is when we take everything to one side, okay? And that's when we did that. You've done that recently also. And that would give me x cubed plus x squared minus x minus 1, and you set it equal to 0. So that's why it's called the zero method. And then you're looking for your zeros. Okay? And the reason this is a little bit harder for people is because if you don't know where they intersect, you're not going to know where that point is. So I gave you the graph so you have some idea, but let's go pick it up and graph it and see what we have. So if we did the intersect method, okay, remember we hit tab. I think I have to turn this. Oh, no, it's not a problem. Cool. All right, so I hit tab and I'm going to put x cubed, come back down, plus x squared, and I graph that one. Looks like that. And then I hit tab, and this time I'm going to put the right side of my equation, and that's going to be x minus 1. And I put that down. And now I'm looking for that point of intersection. And I'm going to go Menu, and I'm going to hit Analyze, and I'm going to hit Intersection, and I'm going to go on the left side, and I'm going to go on the right side. Okay? Now, we've talked about this many times before. Which of these numbers, or both, is the answer? Okay? So if you can remember that, and we go back to our problem, okay, there's my original problem. Do I have a y value in it? I do not have a y value, and since I do not have a y value, I don't want the y coordinate of that point of intersection. So my answer is just going to be the x coordinate, and that is going to be negative, we'll write it down right here, x equals negative 1.84. Okay? All right. So unless you think I'm totally schizo, that was a minus 1, and when you take it over, it becomes a plus 1. So if you'd put it in there, you'd have the wrong answer. Okay, but let's go do that method, and just so that I can show you the difference, and you can decide. Sometimes, especially on the 83 and 84, if you do it this way, and if you can't see the point of intersection in your window, then you don't really have any idea where to look. And so it's hard to find that point of intersection. But if you do the zero method and you don't see it in your window, then you know that you only need to change your x-axis so that you can actually see the zeros in the window. But let's go do it this way. And so on this one, this time I'm going to actually go to a new page. So for those of y'all who don't remember, that's Control Doc, because above that is a page. And I'm going to do another graph. And this time I'm going to put in x cubed plus x squared. I didn't come back down, Pooh Bear. X cubed plus x squared, and then it's minus x plus 1. Now, do I need to do equals 0? Well, this is the part right here that's equals 0, so you don't need to worry about it. But I put it in there, and I can clearly see it. But again, if you don't see it in your window and you do this, you know that you just have to change the x values to go find the zeros. Okay? So we go to Menu, we go to Analyze the Graph, and this time I'm looking for a 0, and I need to be on the left side, and I need to be on the right side, and boom, there's my 0. And we talked about that. We did at the beginning of the lesson yesterday, the last lesson. So we know that the answer is x equals negative 1.84. So we're good, because that's what we got. So either method, you need to pick a method and be familiar with it and comfortable with it and be able to be accurate with it. All right, last problem. What are three consecutive integers whose product is 480 more than their sum? One of the things that I want to show you about this, because you can use this on the ACT, y'all, and not have to know how to necessarily solve things algebraically doing all of the work that you would normally do. Okay, I hope you know three consecutive integers. I have x. Consecutive means it's the next number, so we just add 1. All right, so those are my three consecutive integers. And if it's a product, then I'm going to multiply them together. X times x plus 1 times x plus 2. And that product is, how do we write is in math? Equals 480 more than the sum. And what is the sum? The sum is when I add all these together. So x plus 1 plus x plus 2. Now, I wrote them all out. Okay, now, I like the zero method, so I am actually going to take this to the other side of my equation, and I will say I'm going to clean this part up a little bit, and if I add that, I have 3x's and I have 3, so that's what that becomes. So when I move it to the other side, just to be able to use the zero method, you don't have to worry about that, y'all. You can put it in your calculator just like that. So x times x plus 1 times x plus 2 minus 480 minus 3x minus 3 equals 0. Okay, so let's see if I can remember all that to put it into my Inspire. I'm going to again go to a new page. Control, new page, go to a graph, and I'm going to type x parentheses, x plus 1 parentheses, x plus 2 parentheses, minus 480 minus 3x minus 3 equals 0, but I got the equals 0 covered, and something it doesn't like. cannot accept the change. Okay, give me 1 second. Okay, so I'm really glad that I got that because that reminded me when you enter multiple things in your Inspire, if you ever get that problem, go look and make sure that you have a times in between your expressions. So if I come back here and put a multiplication symbol like that right there, then it will graph it for me. Okay, so I graph it and I'm looking for the zeros, so we're going to hit menu and then I'm going to hit analyze, 0, go on the left side, go on the right side, and the 0 is at 7. So this tells me that x equals 7. So to answer my question, what are 3 consecutive integers? Well, I have 7, and after 7 comes 8, and after 8 comes 9. Those are my 3 consecutive integers. You can test it out and say if you multiply those, you will get 480 more than if you added them all together. So that's the end of 5.3, and if you have any questions, please come see me.